I should.
Okay. So
I'll tell you when it stops.
So, in order, when we are running the computer in the field, you know, everything is running off of that battery, and we are usually trying to squeeze most power out of it. I have it set so that screen basically shuts off after 1 minute. So in order to activate it, you just kind of...
Is there already one place that's better than others?
Right. So I was going to just mention quickly when the program is running where you shouldn't touch. So it's not a big deal, because the thing you can do there is stop the program, and you don't want to do that often enough. You won't screw anything, it will just end your program earlier than you would like to. Okay, so what you do is we have a shortcut for the Swirl View, which is the program that runs all of the instrumentation and then basically collects and records all of the data. And that's maybe a good thing to mention. All the data is stored in the Swirler data directory, which is basically located on the C Swirler data directory, but we have basically a shortcut for it right on the desktop. And the way that works inside of that folder, we basically create a folder every day when we run a Pi-Swerl. So for example, yesterday was, and the naming convention is 4-digit year, 2-digit month, and then a 2-digit day. So yesterday was 2013-04-22. So when we click in there, we see that the test that we were running yesterday. And then same thing, when you're copying your data, you kind of know which directories you need to move on your flash drive.
So if you do multiple samples in a day, will that all go into that file, or will you have multiple, like 1, 2, and 3 files?
Basically, every test, when you run basically few tests in the same day, it creates a folder for that day, and then all the individual tests go into that folder. Okay. But every test has its own data file.
Okay.
Okay, so in order to start the program, it's really easy. We just double click on the shortcut, wait a couple of seconds, and then this screen comes up. And this is basically the screen that allows us to make test selection, which test we want to run. You know, you just click on here on this little arrow, and that kind of lets you know what tests are available, which tests are pre-programmed in the memory. So when you select an individual test, what this does, it kind of plots the win profile of that test, and then it tells you what's the duration of that test. So it's just kind of a quick summary of you know, main parameters associated with the test.
Sorry, George, did you select RAM?
No, I haven't said that. So we have a number of different tests listed on here, and they have these different names. So the convention that we kind of use is that we have this test that starts with age, and that to us is a hybrid test. And if you remember from Rick's presentation yesterday, hybrid is a hybrid of basically these linear increases in wind speed and then constant wind speed. Linear increase and a constant wind speed. So when we go to these R tests, those are what we call ramp tests. So for those tests, we just increase the wind speed linearly. These are the tests where you basically want to look at the thresholds. So you slowly increase your wind speed, and you're kind of seeing how does the dust concentration and saltation respond to that.
But if we wanted to look, so like the hybrid will look at more like a gust pattern. So if you have like 50 mile per hour gust for 2 seconds versus...
Well, what we do with these instruments, we don't try and simulate quick gusts, because that's kind of hard to do.
Right.
It's possible, but I think it's somewhat complicated too.
Okay.
So we have these tests where we gradually increase the wind speed and then we hold it steady. And you see this little table on the side also gives you a summary of what this test does. So for 60 seconds we are at 0 RPM. That's this part of the test. Then for 60 seconds we go from 0 to 2000 RPMs. So from 0 to 2000 RPM for 60 seconds. And then for the next 60 seconds, we hold it at 2000 RPMs, right? And then for the next 60 seconds, we go to 3000 RPMs. And then again for, actually here, it's 90 seconds here, we hold it at 3000 RPMs. And then 60 seconds to 4000. And then we hold it for 90 seconds at 4000. And then we shut off the motor and do a 60-second flush cycle. And then we also have a flush cycle at the beginning.
Why is your first RPM not 90 seconds? Because your second and third are 90 seconds.
Yeah,
and you're holding
question.
still.
Right.
On supply limited surfaces, when you reach a new RPM value, sometimes you get a peak and then it decays. For the higher RPMs, that takes longer for that decay to happen. So in order to see that decay, you wait a little bit longer. On some surfaces, there's no decay, because it just goes up and stays high. But for those surfaces where there is a decay, you want to wait a longer period of time to make sure that you're seeing it go back down. And then sometimes what also happens is that these higher RPMs, you get a little peak, and then decay, and then the surface starts to abrade and falls apart, and then you get another peak. So that's why you make it longer, so you can see it.
Right, and another reason why you make it longer is that at higher RPMs or higher wind speed, you're more likely to get a higher peak. So you want to give it more time for the blower to work it out and to basically mix the clean air into the chamber and lower that concentration. Because if you do it too quickly, you don't get the data on the full decay. Okay, and then what we can also do here is we can click on this modify button, and that shows us this screen. And this screen is kind of similar to the previous screen, but here what you can do, you can change parameters associated with one of these tests. And also one useful thing that you can do here as well is get an idea of what U stars you are getting associated with different RPMs. And then we also have a little calculator here, which allows you to basically say, okay, let's say I would want to simulate 0.4 meters a second U star. So that means that I need to be running around 2000 RPMs. And then, whatever.
It's just a calculator.
Yeah, it's just a little calculator. If you remember that curve of RPMs versus shear stress and U star, it's basically, we have a good linear fit on it, and that's the equation that's programmed into here.
But most likely we're not going to mess with that page at all.
Right. So I think you're most likely to just run this test. So then you can just say, go back without changes, and then you go back to this screen.
Okay.
Or you can go back to modify, blah, 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 and so on.
Is this, that's
And then also here, you set the clean air flow rate. So every one of these tests, you can go through them this way, and they show you what the flow rate is. And we usually set it at 100. But if for any reason you need to change it, then that's where you go to change it. Okay. So, and then we say, so here we want to keep all of these tests, we will go back without changes. You can change things here in maybe duration, RPMs, whatever, and then you would say update test specification or create a new test specification. And then we say go back without changes. Okay, excellent. So we covered that pretty well, and let's say we want to run this H4000 test. We will say next. and then at this point we are going to enter some parameters that are meaningful to us. For example, the skein hole long, whatever, you know. Oh. Oops. I think the space on our keyboard is not good.
Maybe do an underscore.
Well, what I can do is get to my...
I don't even think that's one still work. Maybe that's all the letters you can use.
No, I know for sure.
Maybe it doesn't let you do spaces.
No, it does. I don't know if there's something...
No, it doesn't like you.
Oops.
Hello?
Space.
Hey.
It's not letting us do space. It's funny.
No, that's fine. You can just reheat the leftovers or whatever.
Okay, let's see.
I'm still doing training for the Pi-Swerl, and then I'll probably come home, go bike, and then come back. I mean, yeah, whatever you want. Oh gosh. How much time do
I
we have?
click here, so my
here?
cursor is there.
Okay. Oh.
Okay. And then let's try here.
Probably no more than
1.
25 or 30
I just want to see the space
here
thing.
at Skiing Hall. And then I'll be back, and then I'll pack up my bike, and then it'll be the usual biking stuff.
Nope, no space button for
No,
you.
definitely after. So you can have whatever you want.
What are you turning in?
And I can swap
Space
over.
button.
The space button in the test comment for some
Okay,
reason.
I'll see you in a bit.
Are you starting off with the space button?
Okay.
No.
No. We're
Does it
trying.
work on the keyboard?
Keyboard
No.
doesn't work.
It's not
Yeah.
at all. That's weird.
And then the on-screen keyboard
You
doesn't
can
work
totally
either
pause
for
this,
space.
by the way.
Okay.
Can't think of one.
Say that again. You hit the.
So
Yeah.
we basically name our test, we put the comment on there that we want, and then we press the run button, and that gets us to this main screen, which is the runtime screen. So here we have a number of things going on. So we
That's
have
kinda
the
crazy. We
timer
all just ended up with wireless
timer
keyboards.
counter, which is timing,
Don't have wired
counting the
keyboards
time
anymore.
down, letting us know how many seconds we have left in the test. So we are at 5001, for example. You have a dust track indicator light, which let us know that the dust track, when it's light green like this, that means that the dust track is communicating. And we can see that we are reading the dust track values here. And by the way, the light green trace on the screen is the dust track values being plotted. And then we have the RPM, which are the real RPMs, which is the white trace, and the target RPMs, which is the red trace. And then in addition to that, we have the yellow trace, which is the OGS sensor, or optical gate sensors. Okay, so you see here initially for the first 60 seconds the motor was off, and now the motor is starting to run, and you can kind of see that the RPMs are following the target RPMs. They're a little bit behind, but they're catching up. And then you can see that same thing on the screen, that the red line, which is target RPM, is being followed by the white trace, which are the real RPMs. And then, as I was saying before, here on this map legend we have all traces labeled. White trace RPM, yellow trace OGS data, light green trace is the dust track data, and the red trace is the target RPMs.
Okay, so if the screen goes to sleep, where can we hit?
Yes. So, and another thing that we see here is that we have a stop button. So stop button is where we can stop. Yeah, you see, look at this, guys. So you see, now he intentionally disconnected the dust track, and you can see that the dust track is reading -999, and this value dropped off the scene. and the light has changed. So that means, oh, the dust track is not working. That's not good. You have to check and figure out what's going on.
Did you unplug the data cable? Is that what you did? Okay.
So he's going to plug it back in. But if you forgot to turn on the dust track, you'll get the same thing right from the beginning.
So I'll always make sure that that green light is there.
Right.
Okay.
You want the light green.
So obviously everything would be nice and green if the dust track was on, data cable was in, but we forgot to connect it to the little intake. So
Right.
we would have to know we're seeing kind of crap on the
Right.
screen, but
Right.
there would be no other. Okay.
Yeah, sometimes what's really funny, because chamber is under positive pressure because you're pumping air into it, sometimes even
It'll still pick it up.
Yeah, it'll pick it up, but it'll not be meaningful because you're gonna see these peaks going up and down like you kind of expect, but you're saying to yourself, oh man, these are not as high as I would like. But maybe that's fine because they're just kind of happening like I would expect. And then maybe on the third test you're like, this is happening for too long, let me check it. And you look at the damn thing and the tube is not connected like it's supposed to.
So 20, 30 minutes work down the drain.
Right, exactly. Yeah.
So if you find that happening, you stop it and then run the whole thing over again instead of just letting it go.
Right. So if for whatever reason, safety, weather related or whatever, you need to shut down the Pi-Swerl. If it's really some kind of an emergency and you don't have any other choice, you would turn off the power switch. But we never had to do that. Usually you have the time to basically say hit the stop button, and then see as soon as you hit it, that turns the motor off. You can kind of hear it ramping down, and then it says, oh, what do you want to do here? Do you want to run a new test or you want to exit the software? So if you say exit, it completely exits it. If you said the new test, it would basically show you this screen again. And what the software does, it remembers the last test you ran. So we ran H1000 last time, and it remembers it. It assumes that you want to run it again. If you don't, you can change it. But let's say we want to run it again, you would say next, you would change your text comment, and then you would press run, and then you start running again. And again, what you train your eye to do is, okay, green light on the dust track, I'm reading the dust track data very good. You're looking at the target flow rate, that's 100 liters a minute, and here we are kind of fluctuating plus minus 1 liter, no problem. That's kind of right around 100 liters a minute, that's good. And then usually, you kind of now can go and do something else, but you need to keep in mind that in about 60 seconds after the start, you should hear the motor starting up and ramping.
All of that is in here, on the description of everything that you're supposed to see.
Yeah, as I say, the manual is a great resource. You should really read the manual before
you know what's in here. Yeah.
Right, because it really has all this level of detail that we mentioned, and it's kind of Rick did an excellent job of writing in the nice